Hey, what's up? It's Coach Hyde. Today, doing a little bit on cell transport. It's the first video of the cell transport series of three, maybe, right? So cell transport, talking about getting stuff into or out of the cell, into the intra and extracellular networks. So, um, today, we're going to talk about passive transport. I also do a little video on osmosis and one on active transport. So we have passive transport, active transport. We are not doing active today. This is only passive. So when we say passive transport, we've been getting things into or out of the cell using no energy, right? So if you think about passive, I think about somebody who kind of avoids conflict, kind of sits back, a follower, not a leader. So these are the kind of things that come to mind just thinking of the word passive. Um, so when we think of passive transport, right, it's kind of the same thing. It's just going to kind of happen. It's not being forced. Um, it's not active. That'd be active transport, right? So it's just kind of happening without energy, right? It's just a natural kind of thing, I guess. But anyway, so first thing, diffusion. Diffusion is a type of passive transport. We define diffusion. I do. I don't know what the definition will be if you look it up on Google. Probably something similar to this. But it's the movement of solutes from areas of high concentration to areas of low concentration. So this is how stuff works. Everything moves from high to low. It just does that, right? You're not going to prove me wrong. Unless you put energy into it. But that's another conversation for another day. So, water. Water flows from high ground to low ground. Water doesn't flow uphill. If you see water flowing uphill, you need to leave because something ain't right, right? Things move from areas where there's a lot of it, high concentration, to areas where there's not so much of it, right? You think about mixing up Kool-Aid, right? You put a bunch of Kool-Aid into the water and it spreads out. Now you mix it to make it happen faster, but still, anyway. So when we talk about solutes, we're talking about things we put into the solution. So if you think of, Kool-Aid again, Kool-Aid is just sugar and water, basically. So you put the sugar into the water. So sugar is a solute. If you think about carbonated drinks, the word carbonated means it's dissolved carbon dioxide gas. We're putting carbon dioxide gas into your drink, into your Coke, into your soda. So that's the solute, the things that go in of the solute into the solution. Now, when we talk about diffusion, it's kind of the most simple form. We're talking about the ability to diffuse from one area to the other, right? So it's able to go through the cell membrane, either in or out, and not everything can do that. In order to do this, you must be very small, right? Right, so that is a CH right there. No, it probably doesn't look like it. So you got to be very small and preferably no charge, right? If you're, and we're talking about like atomic level small, right? We're talking about like um, O2, right? So that's O double bond O. This is how we breathe in oxygen in the form of O2. This is two atoms bonded together. I don't know if you know this, but atoms are small, right? I look at the tip of this pen, right? And I was to put a dot. I don't have anything to put a dot on. Right? That ain't gonna work. Let's see here. I was to put a dot. That little dot right there. There's like a trillion atoms on there or something like that, or a billion. There's a lot of them on that little dot. And we're just talking about two. Two bonded together. I mean, that's incredibly small. So it is small enough and it has no charge. It's going to fly in and out of that membrane if it needs to. Well, how do we know if it's going to go in or if it's going to come out? O2 oxygen is not a living thing. It's not going to be like, hey, that cell looks like it's fun. I'm going to go get in that. It don't work like that. What happens is, if you have enough oxygen out here. So we got a bunch of oxygen out here and only like 2 in there. So we have an area of high concentration of oxygen. There's a lot of oxygens, and there's low concentration of oxygens in here right now. So things are going to move from high to low. Water is going to run downhill. Right? So this would to balance out to reach an equilibrium point. The oxygen is going to flow through here, right? It's going to diffuse through, right? Nature wants to be balanced. It doesn't like this buildup of things. This is stressful. It stresses nature out. Nature ain't about stress. It wants to relieve stress. So that's why we have diffusion. It's going to balance out and reach that equilibrium point. So same kind of thing would be, if we breathe in oxygen and then, maybe CO2 builds up, right? Something like this. If we have an area of high concentration of CO2 in the cell, then low concentration out of the cell, right? That's going to diffuse the CO2 out, right? Through the cell membrane. This is diffusion. Now, we need sugar, right? So what are we going to do? Or what happens? Can I draw over here? Yeah. Something like this. Right? This is like glucose, I think, maybe. I could be wrong. Don't hate me if I didn't draw it right. C6H12O6. So now we got a compound with 24 atoms. Compared to 2, that's 12 times bigger than this. So it's not small enough to get through. But we got to get it through. We need sugar to make energy. So what we need is a little help, right? There are proteins embedded into the cell membrane. And all of them, depending on their structure, do different things, have different functions. But one of the functions is a channel protein. And this channel protein here is going to allow glucose in or out. And it still depends on the diffusion, right? If there's more sugar out here, then it's going to diffuse into the cell. If there's more sugar in the cell, it would diffuse out of the cell. It's all about that concentration gradient, right? I don't know how to write this. Concentration gradient. This is just, things move from high to low. That's the gradient, right? So this is called facilitated diffusion, right? It's the same thing as diffusion, moving from high concentration to low concentration, but it gets a little help from protein. It gets a little facilitation from a protein, right? The last one is osmosis. Osmosis is the same thing as diffusion, essentially, except we're not focused on the solutes. We are focused on water, which is typically the solvent. Just COVID everywhere. I'm just kidding. So if we're talking about water diffusing, the concept is no different than any other one. These are all the same concept, moving from high to low, moving along the concentration gradient. If we're talking about water, we're just osmosis. If we're talking about other solutes, pretty much any other solute, it's diffusion. If we're talking about things that are too big or too charged to naturally go through the cell membrane, they need a little help. That's still diffusion, it's just facilitated diffusion. All right, so that's video 1, passive transport. Another one will be a little video about osmosis, specifically kind of aimed at preparing you for the test, and what you'll kind of have to be able to do with that. It won't take long. And then finally, we'll finish up with active transport. All right, see y'all.